Normal distribution. Let's start with one of the most important distribution, the probability distribution in mathematical statistics. And what it is a normal distribution. Let's see what is the definition. If a continuous random variable has symmetric, unimodal, bell-shaped curve, it is considered to have a normal distribution. Okay, let's see how the shape look like. This is the shape of the normal distribution. Now, how many properties it has? Look at these properties one by one. The first one, it is symmetric. Look at this, is symmetric. And I told you in the previous chapter, what is the symmetric? I can divide this figure into two parts such that the two parts are the mirror images of each other, 1 and 2. These two portions are the mirror images of each other. This is a behavior which is called symmetric. It's a unimodal. Unimodal, which means it has only one peak. Look at that, unimodal. And it has a bell-shaped curve. So if a continuous random variable has these three, the shape of the continuous random variable has these three properties. Number one, it is symmetric. Number two, it's unimodal. And number three, it's a bell shape. It is called a normal distribution. Okay, let's see what are the parameters of a normal distribution. When I say the parameters of a normal distribution, what I mean by that? I mean the mean and the standard deviation. These are called parameters of a normal distribution. And in some textbook, they represent a normal distribution. They write a n here, and they write a mu. They write a mu, sorry for that, mu, and a sigma. They express it like this. So these are the two parameters of a normal distribution. Let's see what it says. Every normal distribution is uniquely determined by its mean and by its standard deviation. These two are called the parameters of a normal distribution. So every normal distribution is uniquely determined by these two things. I already written here, mu and a sigma. For example, let's say I talk about a normal distribution 5, 2. It means I'm talking about a normal distribution which has a mean of a 5 and a standard deviation of 2. What I mean by that, I can draw that like this. This is the normal distribution which has a mean of 5 and a standard deviation of 2. That's the meaning of this notation. In some textbook, they use this notation, but probably not in our textbook, okay? So these are the parameters. Let's further understand what I mean by these parameters by looking at one of the applet in StatCrunch. Let's see an applet. Here I am in the applet in StatCrunch. I already launched a StatCrunch. So let's go to the applet and go to the distribution demos. Click on that and click on normal and click on compute. Look at this applet. Note that there are two sliders. One, the red one, is for the mean and the blue one for the standard deviation. Let me move the slider, this red one, and see what happens. When I move the slider, the red, which is the location of the mean, it moves. Look at the value, look at these values, and look at the red line, the moving. If I change the mean, the red line changes, right? And now let's see, when I move the blue slider, what happened? Look at that. The shape of the distribution changes. Larger the standard deviation, the flatter the curve is. And smaller the standard deviation, the thinner the curve is. It's more peaked. Look at that. It's getting more peaked, more peaked, more peaked like this. So this applet gives you a very good idea how the shape of the distribution is affected by changing the mean and the standard deviation. Also, look at here. Look at these three curves, the red one, the black one, and the green one. Note that the black one and the red one, they have the same mean. Look at that. They have the same mean. The mean is 10, but they have different shapes. The red curve has a larger standard deviation than the black curve. Black normal curve is more peaked, whereas the red one is more flat. So the red one has a larger standard deviation as compared to the black one, but they have the same mean. Note that the green curve and the black curve, they have the same height, the same peak, so they have the same standard deviation. But they have a different mean. The mean of a black curve is 10 and the mean for the green curve is 14. So I hope you understand this idea, how it changes. So what is a standard normal distribution? A standard normal distribution has two properties. Number one, it is a normal distribution. And number two, it has a special mean. It has a mean of a 0 and a standard deviation of 1. It has a special mean and a special standard deviation. Such a normal distribution is called a standard and normal distribution. So remember, every standard normal distribution is a normal distribution, but not all normal distribution are standard normal distribution. So a normal distribution which has a special mean, the 0, and a standard deviation of 1 is called a standard normal distribution. Look at that. We have a mean of a 0 and a standard deviation of 1. 1 each on this side and tick mark on this side, right? Let's see few examples where the question that comes to the mind, okay, where I'm going to see these application, the application of a standard normal or a normal distribution. Show me the application. Now remember that the standard normal curve or a normal curve come into existence in our everyday life. For example, if you take a human IQ score, they are normally distributed. Right? They are normally distributed with a mean of 100 and a standard deviation of 15. The SAT score, the standardized test exam, has a mean of a 15. The score of the SAT score are normally distributed, which have a mean of a 1500 and a standard deviation of 300. So you can see these are the application in everyday life. So standard normal curve come into our study in everyday life. And we see they are commonly used. So let's understand what is the importance of normal distribution. Number one, these are the most important type of probability distribution in mathematical statistics. Why they are important? The question comes to the mind. Number one, there may be more than these things which I am mentioning, but the comes to my mind instantly is this. Normal distribution, they apply to wide variety of, they are applied in a wide variety of situations, wide variety of application. They appear in our everyday life very often. And what happens? Other distribution, they tend to become a normal distribution under certain conditions. So you must have heard of saying all roads leads to Rome, right? So it's a similar thing like here. Every other distribution, they tend to become a normal distribution under certain condition. So these are the two main reasons which contribute to the importance of a normal distribution. Now let's see what is the association between the area and the probabilities. So let's see what is the density curve. Look at this one. The shape of the normal curve, this shape of a normal curve, this shape I'm talking about, this density curve describes the shape of a normal curve. This curve, this is also called the density curve. Density curve. Right? A curve describing the shape of a continuous random variable is called a density curve. And it has these properties. Okay, what are these properties? Number one, the total area is 1. This area I'm talking about, this total area, the entire area is 1. And number 2, no part of the curve lie below the horizontal axis. Look at that. This is the horizontal axis. Look at the axis. This is the horizontal axis. This is the horizontal axis. And this is our curve. You note that no part of the curve lies below. Look at that. What happened actually, this, if you extend this one, if you extend this line, This graph gets closer and closer and closer, but it never touches from both sides. Let's say this is the horizontal axis. This graph goes closer and closer, but never touch. Such a behavior is an asymptotic behavior. We will see later part how we're going to do that. What is an asymptotic behavior? Now, the total area under the density curve and sum of all probabilities. Recall from our earlier discussion, we have seen that for a probability distribution, the sum of all probability were equal to 1, and the total area is also equal to 1. So the question that comes to the mind, is there any relationship between these two concepts? And the answer is yes. And what is that relationship? The area under the standard normal curve is the same as probability. This is, by the way, the most important concept in this particular slide. This is the most important thing you need to remember. The area under the standard normal curve is the same as probability. Now, in order to find the area, so you might be wondering, let's go back. You might be wondering, okay, Professor, you're talking about the area, but how am I going to find the area? Because the area is very difficult for finding for this particular figure. Let's say it was a square, then I could have found the area by multiplying the length and the width. Had it been a rectangle, I would have found the area multiplying the length and width. The area is simple. But this is a horrible picture, right? This is a very difficult figure to find the area. And actually, honestly speaking, you require a knowledge of calculus. Require the knowledge of calculus to find this area. Okay, but I'm not going to teach you how to do this. All these areas are provided to us in a table, and that's the table which I'm going to show you now. This is the table I'm talking about. This is the table, right? So this is the table for sometimes the people call it as the A2 table, right? A table A2, but this is the area for area to find the area of a standard normal curve, right? For understanding purpose, I have divided this table into 3 parts. Just please pay attention to that. Right? What are those 3 parts? Let's understand that. This is the first one, is this column, extreme left column. This is the first part I want you to pay attention. The second part is this top row, right? And the third part is this body of this table. So I can divide this table into 3 parts. The extreme left column, which contains the extreme left column, this one, which contains the z-score, the top row, which contain the decimal, the 100th position, and this body of the table, which contain the area. How we're going to use this table? Let's see a few examples. We are given this z-score here. We are given z-score here, and we are asked to compute the area. So this z-score is given to us, which is minus 1.30. How we're going to find this area? Let me show you. We have to go to the table, and then I will show you. So recall our z-score. Our z-score was equal to minus 1.30. So how we're going to tackle this? We're going to look at this minus 1.3 in this z column and this 0 on the top row. Minus 1.3 is this one, and 0 comes from here. Look at that. At the intersection of these two values is my required area, 0.0968. So area comes out to be 0.0. So the area comes out to be 0.0968. Okay, I hope you understand that. Let's do another problem. You have to find the area to the left of the z-score, and in this case z-score is minus 1.82. Again, we go to the table. So we are back in the table, and recall our z-score was 1.82. So what I'm going to do, I'm going to first locate this 1.8 in this z column, but I have to move to the positive side of the z-score. This is not the one I'm looking for. So 1.82, since 1.8 is here, look at that, and 2 is here. 1.2, and this is the area I'm looking for, 0.9650, 0.9650. So again, this is a 1.8, and the 2 is this. This is the area I'm looking for, 0.9656. So I hope you understand that. Thanks for watching.